Everybody, chapter 6. So, homework in 6.1. I'd like to look at some problems, but before we do that, just basic review of our density curve with standard normal distribution. This is our density curve. The area under the curve equals 1. So, once I add up all the values under the curve, it equals 1. We refer to that as the area under the curve, but it's also broken down to probability. There's symmetry on the curves. Now, forgive me, that may not look symmetric because I drew it by hand, but there's symmetry under the curve. So whenever I split this in the middle, these two are equal. If you notice, mu equals 0 right in the center, z equals 0, and p, the probability, is 0.5000. We added those three zeros because your values in the table A2, your standard normal table, are to 4 decimal places. To the left of the center, you will have negative z-scores, and you will have probabilities that are less than 0.5 or less than 50%. To the right, you will have z-scores that are positive, and you will have probabilities that are greater than 0.5. And just like with probability, we range from 0 to 1. For our standard normal distribution, we're always dealing with mu of 0 and sigma of 1. To read our density curve and the area underneath it, the way our table is set up, the readings are from left to a right vertical boundary, wherever that is. So that's how our tables read. We're always starting from here and reading this way. You need to make sure you know how to use table A2. Later in the chapter, another important thing is to convert to standard normal. And this is very practical because very rarely do you end up with these two whenever you do your research. Okay, so this is a great way to be able to convert to z-scores. Z-scores are the common practice to use. X is just the value that you're dealing with, and then we have our mean and our standard deviation. So I'm going to kind of cover on like the first problem, the reading of the standard normal table, but otherwise that should have been in the publisher's videos. So let's look at some problems. So here we have standard normal distribution. And what I have here are three problems in which the highlighted area is shaded in blue, and that's what we're going to find. The area of the shaded region. And forgive me, I've actually already made this video once before, and whenever I did it, it did not record any of the video. And I didn't want to redraw all those, so you can see everything that I erased. And I was stupid enough not to take a picture of all the work that I did. So, but onto this. So we're going to find the area of the shaded region. And this is our density curve, and this is our vertical boundary, and it is going from left to right, and this is our z-score. So I'm going to use table A2, and I'm going to look up that z-score and find the corresponding probability. Now I have the online version, and then I have this version. So I wanted to be able to show you, if you actually bought the book, you should have this, and it's all your tables, and all I've done is I've put the online version on there. For some reason, whenever they did this, they did not put table A1 into this package, so it's just your first appendix. This is A2, your second, but it's detachable. There's a perforated edge and you can detach it. Again, though, I don't like how they had it folded. This sheet is the back sheet, and it's longer than what you need, so you have all this unfolding just to be able to look at your 2 pages of your z-scores, page 1 and page 2. Okay, so our z-score was 0.27, so that's what we're going to look up. So I'm going to find 0.2, 0.2, and then and that is the tenths place. In the hundreds place was 7, so 0.07. I'm going to find where those meet, so I'm going to try to. There's my 0.2. and then here is my 0.7 or 0.07. I'm going to find where those meet, and that is the probability or the area under the curve that corresponds to that z-score, the z-score of 0.27. So 60, 64, 60, 64, 0.6064. That is my probability. And again, I read from left to right. If this wasn't going from the left to the right, then my table wouldn't give me the exact answer. So let's look at the next one. And I went ahead and highlighted this to draw your attention to it. In that we are not reading from left to right. What we're reading from is from the right to a left vertical boundary. So what we look up using our table is not going to give us the correct information. But there's two ways to solve it. And the first way I will call the complement. And we should remember that. Complementary. So what I'm going to have is whatever I find, I'm actually going to look up this z-score and find that value, and then I'm going to subtract it from 1. So this, I'm going to look up z equals a negative 1.31 and find the corresponding probability to that. But then once I find that probability, I'm going to subtract it from 1. The reason is that the entire area under this curve is equal to 1. What I'm actually looking up, whenever I look up the z-score of a negative 1.31, I am looking up reading from left to the right. This is the area that I'm actually going to find, what I'm shading in right now. Whenever I do it this way, whenever I look up that z-score, that's what I'm going to find. But I can subtract it from 1. Since the total area under there is 1, I can subtract this from 1 and it'll give me what's shaded in blue. So page 1 of your z-scores. Now I'll use the chart again. A negative 1.3, so I have a negative 1.3 and then 1, right? Yep, 0, 1. A negative 1.3, 0, 1. There's my 0, 1 up there. Okay. And that gives me 0.951. 0. Oh, goodness gracious. 0.0951. And then I have to make sure to use a calculator. Oftentimes I just get in a hurry and like to just try to go through, and I will mess up some numbers. This equals 0.9049. Okay, so that's one way to do it. And you'll see we use this a lot. We use that everything sums to 1 in subsequent chapters. But there's also another way that you can work this. Because under that density curve, I talked to you about there being symmetry. If my density curve shaded area is flipped, it's going from right to left vertical boundary, just use the density. Instead of using a negative z-score, use the positive, use the opposite. So what I'm actually going to look up is a z-score of z equals 1.31. So 1.3 over to 1, and that is 9049. 0.9049, same scores. Either way, either method you want to use, the complement or symmetry, both of them work. Alright, last one. I have an area in the middle here. I need to look up two z-scores. Make a little drawing for you. And anytime you don't have a density curve on a problem, draw it in there. So this is what I have here. I have the z-score of 1.21 for this one, and it's shaded in all the way through there. And I'm going to subtract from it this one. forgive my drawing, a negative 0.84. Because what I'm actually going to look up whenever I use my table is this. Notice I don't have this area, just like here, I don't have that area will not be included in my calculations. But whenever I do this one, I'm actually counting this area that's not supposed to be in it. That's why I'm going to find it and then subtract it from there. So I have to look up two z-scores. I'm going to first look up the z-score 1.21 and see what I have. And I'll just do the to the side 0.8869, and then my z-score of negative, so it's on page 1, will be 0.2005. Now all I do is subtract those. Again, use my calculator, and I end up with an area of 0.6864. Okay, one thing that's nice about these problems is that the drawings of the density curves usually match up. There, a large portion of this is shaded in, so an area of 0.9 or 90% of it, that seems decent. This is just past halfway, so 60%. Good. This one here, yeah, I can kind of see that. It's kind of hard to be able to judge that, but I can say over half of that is shaded in 68. All right, guys. Watch your publisher's videos, critically think and structure your homework, and good luck on your homework problems.